Okay, at the end of the last video, I gave you this problem to work on. F of x is e to the x sine x, and we're working on the finite closed interval from 0 to 2 pi, because that's finite and closed, and because that is a continuous function. The extreme value theorem tells us for sure that an absolute max and an absolute min exist. So I can just create a table of values and check the usual suspects. The usual suspects are going to be my endpoints, which are 0 and 2 pi, and any critical numbers, and those I'm going to have to, of course, figure out what they are. Now, at 0, we get e to the 0, which is 1, times sine of 0, which is 0. 1 times 0, I usually get 0. At 2 pi, we get e to the 2 pi times sine of 2 pi, which is 0. So we get another 0. Okay, so let's look for some critical numbers here. So I'm going to take the derivative. So f prime of x, again, I'm going to need to use product rule. So I can say this is going to be the derivative of e to the x times sine x plus e to the x times the derivative of sine x. So the derivative of e to the x is e to the x times sine x plus e to the x derivative of sine x is cosine of x. That is always defined, so I don't get any critical numbers from it being undefined, but I always want to check so that I don't forget that those points count as critical numbers. So I'm going to look for where this thing is 0. And at first it might look kind of intimidating because I'm seeing exponentials and trig functions, but again, that e to the x shows up in both terms. So I can just factor it out. So I get e to the x times sine x plus cosine x equals 0. So that means e to the x equals 0, except I know that it never does because e to the x is always positive. Or sine x plus cosine x equals 0. Now that I'm going to have to think about and solve. Notice this means that sine of x is the opposite of cosine x. Now that's going to have infinitely many solutions, but only a finite number of solutions in this interval. And I'm going to just start by thinking in terms of quadrants. I'm not going to find any solutions if x is an angle in quadrant 1, because sine and cosine are both positive there. I need to be in a quadrant where sine and cosine have opposite signs. So, will I have a solution in quadrant 2? Yes, I will. What about quadrant 3? No, because sine and cosine are both negative there. Quadrant 4? Yes. So I'm basically going to have two solutions in this interval, one in quadrant 2 and one in quadrant 4. And now if sine and cosine are exact opposites of each other, that means they have the same absolute value. So the reference angle, alpha here, has to be the acute angle that has the same sine and cosine. We should recognize that that's going to mean that alpha is pi over 4. So here, my x is pi minus pi over 4, which would just be 3 pi over 4. Here, my x is 2 pi minus pi over 4, which is 7 pi over 4. So I'm going to have two critical numbers, 3 pi over 4 and 7 pi over 4. And now I get to evaluate things there. So when I plug in 3 pi over 4, I'm going to get e to the 3 pi over 4, which is a perfectly acceptable number. It's actually a pretty cool number because it has an e and a pi in it. Very nice. Okay. And I have to multiply that by sine of 3 pi over 4. So if I look over here, 3 pi over 4, that was in quadrant 2, so sine is positive. And because the reference angle is pi over 4, it's going to be root 2 over 2. Now when I plug in 7 pi over 4, I'm going to get e to the 7 pi over 4, another perfectly acceptable number. And I've got to multiply that by sine of 7 pi over 4. Now we're in quadrant 4, sine is a negative number. Reference angle is still pi over 4, so I'm going to get negative root 2 over 2 for that. Now, if you were freaking out because these numbers look kind of weird, stop freaking out. We have this very difficult task. I have 0, a positive number, and a negative number. And I have to pick which one is the biggest and which one is the smallest. So the numbers look intimidating. They definitely do. But sometimes I can tell what's the biggest and what's the smallest just based on the signs of the numbers. And so that makes things a lot simpler. So that tells me that this is going to be my max and this is going to be my min. And again, I'm going to clearly distinguish between the value and the location. So f has an absolute max of e to the 3 pi over 4 times root 2 over 2. It occurs when x equals 3 pi over 4. And f has an absolute min of negative e to the 7 pi over 4 times root 2 over 2, and it occurs when x equals 7 pi over 4. Excellent. Okay. So I want to work through one more example. I'm going to do the same thing I did at the end of the last video. I'm going to give you the problem now, suggest that you turn the video off, do the problem, and then come back for the next video to check your work. Okay. So I want to take a look at f of x equals x times the natural log of x, and I have to look at my notes. What interval did I want? I want the interval 1 to e squared. Okay. So continuous function, finite closed interval, use the extreme value theorem to find the location and value of the absolute max and min. See you soon.